Welcome to my video lecture. This is Amarnath, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology. Under the course Matrices and Calculus, we are learning the topic rank of a matrix under the Unit 1. So the previous video lecture, we have been discussed about the rank of a matrix and how to find the rank of a matrix using echelon form. In the present video lecture, we are going to discuss about the same rank of the matrix but using normal form, how to determine the rank of the matrix. What do you mean by normal form? Then how will you find? That all we discuss in this video lecture. Let us go for the definition of the normal form. Here what do you mean by normal form? Then how to identify the normal form of a matrix? Generally for every matrix, for every non-zero matrix, there could be some rank. It will be unique. So rank of the matrix is unique. If the rank is R, the matrix can be represented of the form IR, identity matrix of order R, or IR0, IR000. These three forms are called normal forms. By applying the row operations and column operations, we can reduce the any matrix of rank of order R to this form. IR, identity matrix of fourth order, IR some 0 columns extra, IR some 0 rows and 0 columns extra. Then these R forms are called normal forms, and this is a ortho unit matrix. These all are ortho unit matrix. It is a 2 by 2, 2 rows, remaining 0 rows may be 0 columns. That all it is called as a normal forms or first canonical form. Let us say IR. Suppose how will be the IR? Nothing but it is identity matrix of a rank R. Let us say I2. I2 means we know very well that is a 1 0 0 1. It is also a normal form. IR is a normal form. Let us say I3. I3 is also a normal form. 1 0 0 0 1 0 0 0 1. Like that I4. These all are the I5, I6. These all are the normal forms. Every identity matrix is a normal form. Right. Next, we will come for the IR0. Suppose, what do you mean by IR0? Let us take some example. I20 means it involves some identity matrix of 2 by 2, the 1 0 0 1. Then it can have some additional 0 columns, right? Maybe 1 0 column, maybe 2 0 columns, or how many it may be. These all together will be called as I20. And basically it will have an I2 matrix, then additional 0 columns, maybe 1 0 column, 2 0 columns. How many are there? That will be represented by 1 0, I20. Similarly, suppose I30 means I3 matrix will be there and remaining some 0 columns, right? 1 0 0 0 1 0 0 0 1 and additional 0 columns, right? So like this I30. So IR0, I20, I30, I40, these all are normal forms. Additional 0 columns. Sometimes additional 0 rows also may exist under the identity matrix. So let us say that is we have I200. Let us say this comes under IR00, right? So this can be I200 means here this is a 1 0 0 1. This is I2 and additional 0 rows and additional 0 columns. It can be how many it may be. Maybe 1 0 row, 1 0 column, or 2 0 columns, or 2 0 rows extra. These all are called as IR00. That means basically it involves one identity matrix. Apart from the identity matrix, it may have some additional 0 columns and additional 0 rows that are called IR00. So IR means it may be I2, I3, I4, anything. Suppose let us take I3, I300. The I300 means it involves I3, 1 0 0 0 1 0 0 0 1, I3, and it will have some additional 0 rows, maybe 1 or 2 or anyhow maybe like this. It can have more extra 0 rows and 0 columns also. Even how many it may be there, we call I300. Basically, it involves one I3 matrix, identity matrix of 3 by 3, right? So These all forms are called normal forms. Now our task is to reduce the given matrix to normal form. So we can apply the row and column operations. Whereas in echelon form we can apply only row operations. But here in the normal form we have a flexibility. We can apply both row operations and column operations. And what could be the rank of the matrix in normal form? Order of the identity matrix. Suppose I2 0 0. The rank of this matrix is 2. Because it is I2, means these 2 will become rank. I3, this 3 will become rank. Rank of the matrix will become 3. Right? So these are the normal forms where we can find the rank of the matrix. Means here every identity matrix is a normal form. But every normal form is not identity matrix. See, this identity matrix, these are our first one, IR identity matrix. It is a normal form. But whereas remaining these are normal forms, but these are not identity matrix. So every identity matrix is a normal form, but converse is not true. Every normal form is not an identity matrix. So what are the key points to be remembered? One is to reduce the given matrix to normal form, we can apply both row and column operations. And what could be after converting into normal form? IR, IR0, IR00, anyone. What could be a rank? Means this R will be the rank. And I2 na, I3 I4 I3 means rank 3, I4 means rank 4. So this is the concept of normal form. Let us go for some problems to discuss this normal form. So look at this one. Here there is one problem is given. Find the rank of the matrix by reducing into normal form. Sometimes they will call normal form and first canonical form also they can call. Right? So here generally what is the procedure I follow? In the echelon form I have given one pattern. Similarly here I will give one pattern to reduce to normal form. But there is no strict rule or strict pattern like that. To make you understand, you are using the first diagonal element, the first row, first element, not exactly diagonal. Sometimes it may not be square matrix, exactly you can't define the diagonal. Whatever it may be, first row, first element, take, it should be non-zero. So 0 means you have to interchange and get some non-zero element. Using the R1, make below how many elements are there, that all will make 0. Maybe 2 rows, 3 rows, how many are there, depends on the problem. Right, like exactly like echelon form, the off procedure. Next, using second row, second element, it should be non-zero. Using that element, make below element 0. Next, third row, third element, make below element 0. So here, so the first part is exactly like echelon form. So here itself you will be knowing the rank of the matrix. Suppose after coming to the once of the part is completed, then you will be knowing it is an echelon form. You will be knowing rank 2 or 3 or something. Suppose rank 2, then your normal form will be I2 0 0. Rank 3, I3 0 0. Or I4. So definitely any one of the normal form will get. But it is an echelon form. Then we have to reduce to normal form means only diagonal element should be 1, remaining element should be 0. Here these are we are doing using row operations, we know. Now we have additional operation column also. Using column operation and using C1, we will make C2 element 0, C3 element 0, C4 element 0. How many are that? All we will make 0. At the below elements, now using column operation, side elements. Now coming to second row, second column, second element. Using second column, second element, using column operations, make side element 0. Next, third column, C3. Using C3, make the side element 0. How many are there? Maybe depends on the problem. That all will make it 0. And using column operations. Right? So finally, you will be getting some diagonal element will be there. But in the normal form, what we require in the diagonal? Once we require. Suppose here 10 is there, divide by 10. In the say here we have 5, divide by 5. So suppose minus 6 is there, divide by minus 6. Automatically, the diagonal elements will become 1, 1, 1. Remaining elements will become 0, 0. So it depends on the problem. You may be having I2, I3, I4, that we will decide. So that could be the normal form of the given matrix. Right? So we can apply both row and column operations. So now let us reduce this problem using row and column operations right now. So using the task exactly like as echelon form, using first row, make the below 3 elements 0. Right? R2 implies, we know the operation how to do. R2 implies R2 minus 2R1. 4 minus 4, 0. It is 4, it is 2. Multiply by 2 first row, 4 minus 4, 0. R3. R3 is 1. So it should be multiplied by 2. 2R3. So it will become 2 minus R1. R1 element is 2. 2 into R3 means 2 into 1, 2. 2 minus 2, 0. Our aim is to make zeros. R4. R4 implies R4 is 1. Similarly, multiply by 2. 2R4 minus R1. Every time what we are using here, R1 we are using. So which row you are using, that should not be changed. That is the criteria. Now A is equivalent to first row. First row no change, 2, minus 2, 0, 6. Second row, R2 minus 2 R1. 4 minus 2 into 2. 4 minus 4, 0. 2 minus of minus plus 2 to the 4. 2 plus 4, 6. Next, R2 minus R1. 0 minus 0, 0. R2 minus 2 R1. 2 minus 2 into 6, 12. 2 minus 12, minus 10. Okay, once again check. R2 minus 2 R1. 4 minus 4, 0. 2 plus 4, 6. 0 minus 0, 0. 2 minus 12. 2 minus 12 means minus 10. Next, third. 2 R3 minus R1. Multiply R3 with 2 and subtract R1. 2 into 1, 2. 2 minus 2, 0. 2 R3. 2 into minus 1. Minus 2. Minus of minus. Plus 2. Minus 2 plus 2. 0. 2 R3. 0. Minus 0. Next. 2 R3. 2 into 3. 6. 6 minus 6. 0. Next. 2 R4 minus R1. 2 into 1. 2. 2 minus 2. 0. 2 into 2 R4, 2 into minus 2, minus 4 plus 2, minus 4 plus 2 means minus 2. 2 R4, 2 into 1, 2, 2 minus 0, 2. 2 R4, 2 into 2, 4, 4 minus 6, minus 2. But we know the procedurality, any 0 rows are there, that should be below the non-zero rows. First, better to make R3 is 0 row under the non-zero rows. Make it as a R4 at interchange. R3, interchange means double R rows. R4. Exactly, you are replacing R3 with R4. R4 with R3. Alright. 2. First row, second row, we are not doing any change. Next, 0, 6, 0, 6, 0, minus 10. Next, third row, we are interchanging. 2, minus 2, 2, minus 2. Interchange. 0, 0, 0. Right? Exactly, R3, R4 interchange. Now, second element task. First element task completed. Second element, second row, second element. Second row, second element is 6. Using 6 and using R2, make below R3 element 0, R4 element 0. Already R4 element 0. Then R3 element we have to make 0. That is R3. R3 is how much? That is minus 2. R2 is 6 and multiply by 3. 3 into R3. 3 into R3 means minus 6 plus R2. Minus 6 plus 6 will become 0. Opposite sign means addition. Same sign means subtraction. 2 minus 2, 0, 6, right? 0, 6, 0, minus 10. Because first two rows no change. Second, third row. 3 R3 plus R2. 3 to the C. 1 second. 0, right? So here, this is a 0 element. Interchange 0. 0 minus 2, 2 minus 2. This is a element on interchange. Here we got 0 only. Right? 0 minus 2, 2 minus 2, 0, 0. Now apply the operation 3R3 plus R2. 0 plus 0, 0. 3 into minus 2, minus 6 plus 6, 0. 3 to the 6, 6 plus 0, 6. 3 into R3, minus 6 and minus 10, minus 16. Right? Next, fourth column, fourth row, no change. Right? Now, see, look at this one. 1 zeros, 2 zeros, 3, 4 zeros. It is an echelon form. Suppose here itself you want the rank. Here rank will become just to make you understand. Here I am writing. It is an echelon form. Rank is the number of non-zero rows. 3. Suppose he is asking the echelon form till here we stop. Okay, rank also we know. Rank is 3. So now you want to convert into normal form means the remaining elements above the diagonal elements also we have to make it 0. Okay, using column operations. And here since you know the rank, what could be the normal form? Definitely I3 we have to get. In normal form we need IR form. At I3 we have to get. And but here 4 rows, 4 columns. At 1 0 extra row, 1 0 extra column. And what could be your answer here? That here itself you can guess that is I3 0 0 you have to get. So then the students will be knowing here itself what could be the normal form. But it is not in normal form. We have to make it using column operation. Now row operations completed. Now column operations. Using C1, make C2 element 0, C3 element 0, C4 element 0. Now C column operations we are using. Here I am writing, right? Right. Here C1, C2. Using C1 we are making. C2 implies C2 plus C1. Then minus 2 plus 2, 0. C3 already 0. Only C4 we have to change. C4 implies C4 is 6. This also may be 6. At 3 minus 3, C1. Now A is equivalent to, so since is a column operations, write column wise. First column no change. Second column C2 plus 2 C1 minus 2 plus 2 0. Remaining are 0 elements, no change. 6 plus 0, 0 plus 0, right? No change. Third row already 0 element. Third column we are not doing any operation. That is 0, 0, 6 and 0. C4. What is the C4? C4 minus 3 C1. 6 minus 6, 0. And remaining elements minus 10, minus 0, no change. Minus 10, minus 16, right? 0. So here no change in the matrix, right? Look at this one. Now first column task completed. This side element 3 becomes 0. Now we'll come to second column. But before that one, here 6 minus 10, some student feel the bigger numbers how to do. But here in the first column only one element is there. Second column one element. Third column one element. Finally also we need ones in the diagonal. So here itself we can make the diagonal elements as 1 by dividing with the same number. So C1 implies C1 by 2. C2 implies C2 by 6. C3 implies only one element is there, we can do this operation. C4, if you do division, you will get the fractions. So leave it. So only three columns we are changing. Whenever you are doing column operation, column wise. First column divide by 2. 2 by 2, 1. 0, 0, 0. Second column divide by 6. 0. 6 by 6, 1. 0, 0. Third column 0, 0 divided by 6. C3 by 6, 1, 0. And this one 0, minus 10. We are not doing any change. Minus 16, 0. Okay. Now our task is C1 task completed, side 3 element 0, C2 element, side 2 element 0. Already C3 element 0. Only your task is to make this C3 element 0. Now C3 implies C3 minus, sorry, C4, that is a C4. C4 is our element where we have to make it 0, right? So C4 element is minus 10. Using C2 we have to do. C1 task completed, again don't touch the C1. C4 implies C4 plus 10 C2. Minus 10 plus 10, 0. This is equivalent to, so first column no change. Second column no change. Third column no change. Fourth column C4 plus 10 C2. 0 plus 0, 0. Minus 10 plus 10, 0. Minus 16 plus 0, minus 16 and 0. Right? Now only one element is there in the column. That is the way how to make it 0. And using C4, I have to make C3, we have to make C4 0. C1 side element was over, C2 side element over. Using C3, we have to make C4 0. Now C4 implies C4 is minus 16. This also should be plus 16. C4 plus 16 C3. Because C3 is 1. 16 into 1, 16 minus 16 plus 16 will become 0. Right? Now here, first column no change. Second column no change. 0, 1, 0, 0. Third column no change. Fourth column. Fourth column is minus C4 plus 16 C3. At a 0 plus 0, 0 plus 0, minus 16 plus 0 and 0 plus 0. See, look at this one. Exactly, it is which form it is? Very clearly, it is the I3 matrix is there here. I3. So I3 and the side element 0. Right? So, which is a normal. This is called a normal form. Right? Our so far explained 3 forms we explained. IR00, normal form. So in the normal form, what could be the rank of the matrix? Order of the matrix is rank. So what is the rank of this matrix? Given matrix, which is rank of the matrix is equal to 3. I3. IR00 form. Okay. I hope you understood. Next we go for the one more problem to explain this normal form. Right. Now look at the second problem. So this also they are asking reduce to normal form. Normal form is, again I said, now first task is almost like echelon form. So but here in the first row, first element 0. So 0 means we can't do the operations. Non-zero element should be there. The pivoting element must be non-zero. So we can interchange. So R1, R2, R1, R2 you can interchange. R2, R3 you can interchange together non-zero element. So R2 implies R2 interchange. So R1 interchange. R1, R2 if you interchange, or your wish. Anything we can interchange. R1 and R2 interchange, R1 and R3. R1, R2 I am interchanging. So A is equivalent to, so R1 coming to first place, 4026. And second row in the first row. So first row, 0, 1, 2, minus 2. Third row we are not doing any change. 2, 1, 3, 1. Now it is a non-zero element. With the R1, make below element 0. Like same pattern, using first diagonal element, make below 2 element 0. Okay, already R2 element is 0. Which one you have to make 0? R3 element 0. So R3 implies R3, make it double. 2R3 minus R1. R1 is 4. 2 to the 4 minus 4, it will become 0. A small matrix we can do very easily. 4, 0, 2, 6. Right? 4, 0, 2, 6. R1 no change. R2 also already 0, no change. 0, 1, 2, minus 2. Which one we are changing? R3 we are changing. What is the R3 change? 2R3 minus R1. 2 into 2, 4. 4 minus 4, 0. 2 into 1, 2. 2 minus 0, 2. 2 into 3, 6. 6 minus 2, 4. 2 into 1, 2. 2 minus 6, minus 4. Okay. Now first task completed. Coming to second diagonal element, make below element 0. So using R2, make R3 element 0. So R3 is 2. R3 implies R3 minus 2R2. 2 minus 2, 0. A is equal. First row, no change. 4, 0, 2, 6. Second row, no change. 0. Because we are using that row. Which row we are using? That row should not be changed. So R3 minus 2R2. 0 minus 0. 2 minus 2 into 1. 2 minus 2, 0. 4 minus 2 into 2, 4. 4 minus 4, 0. Corresponding elements. R3 minus 4 minus of minus 2 into 2, 4. Minus 4 plus 4, 0. Okay, and R3 is minus 4 here. Minus 4 and minus of minus plus 2 to the 4. Minus 4 plus 4, 0. You can do some rough work and don't do the mistake here. Right? Now here itself we can tell the rank. So it is in echelon form. 1 zeros, 4 zeros. What is the rank of the matrix here? Itself 2. Now what could be your coming normal form? Here rank you are getting, definitely you should get I2. And below one row is 0 and side elements also 0. The I2 0 0 you have to get. Because here we are coming to know about the rank of the matrix under the echelon form. But the problem is he is asking you to reduce to normal form. Right? Definitely you have to do side elements also 0 and diagonal elements as 1. Okay, now rows over. Rows task is over. Now we will take the column operations to make side element 0. So using C1 we will make C2 element 0, C3 element 0, C4 element 0. Column operations. Right and column wise. Column operations column wise, row operations row wise. Now using first column, make second element 0, third element 0, fourth element 0. At a C2, C3, C4. Already C2 0. So we have to make only C3 and C4. C3 implies C3 make a double. 2 C3 minus C1. 2 to the 4, 4 minus 4, 0. C4 implies C4 is 6. This is 4. So 2 times 2 into C4 at a 12 minus 3 into C1, 12. Common factor, common multiple, 12. 6 to the 12, 4 to the 12. So that's why C4 multiply with 2, 2 6 is 12. So this one multiply by 3, 3 4 the 12. Right? 12 minus 12 will become 0. Column operations rise column wise. First column no change. Second column no change because that is a 0 element is there already. Third column 2C3 minus C1. 2 into 2 4. 4 minus 4 0. 2C3 2 into 2 4. 4 minus 0 4. 2 into 0 0 minus 0 0. Right? Next 2C4 minus 3C1. 2 into C4 12. 12 minus 12 0. 2 into C4 2 into minus 2 minus 4. 2 into 0 0. 0 minus 0 0. Now, right, here using first column task is completed. Second column using C2 make C3 element 0, C4 element 0. Here I am showing how. So using C2 element make C3 element 0, C4 element 0. Now C3 element is 4. C2 element is 1. Again C1 is completed. Again we should not use C1. Okay, we have to use C1 or C2 only. C1 use, then this element will come here. Right? So that's why use C2 only. C3. C3 is 4 minus 4C2. Okay. Next, C4 minus 4. Minus 4 means C4. This should be plus 4 at a 4C2. Same sign, 4, 4, same sign, subtraction. 1 minus 4, opposite sign, so plus. It is very simple. First column, no change. First column, what is the column? 4, 0, 0, no change. Second column, 0, 1, 0. Third column, 0. 2C3 minus C1, 0 minus 0. Sorry, C3 minus 4, C2. C3, 0 minus 0. C3, 4 minus 4, 0. And C3, 0 minus 0, 0. Now coming to C4. C4 plus 4, C2. 0 plus 0, 0. Next, minus 4 plus 4, 0. 0 plus 0, 0. Right? So here, now in the normal form, diagonal element must be only 1. So C1 task completed, C2 task completed, C3 task completed. So we want 1 in the diagonal. So first column divided by 4, like as the previous problem. C1 divided by 4. So then A is equivalent to first column 1, 0, 0, 0, 1, 0. The remaining columns no change, 0, 0, 0, 0, 0, 0. So clearly here, what identity matrix we are getting in the form I2 we are getting. Then A is equivalent to I2 we should write. Some extra 0 columns are there, write 0. 0 rows are there, write 0 rows. This is clearly in the form of, which is in the form of IR00. So what is the rank of the matrix? Order of the identity matrix. It is I2. That's 2 by 2 identity matrix. So therefore, rank of the matrix is 2. The order of the identity matrix. So clearly, it is in the normal form and rank of the matrix is 2. At 2 independent rows are there in the matrix. Right? So here I am giving 2 problems which you can change into normal form and you can verify the rank. Right? Your rank answer also is given. Right? So in this session, we have discussed about the normal form and how to find the rank of a matrix using normal form. In the next session, next video lecture, I am going to discuss about inverse of a matrix using Gauss-Jordan method. So in the intermediate level, used to find A inverse is equal to adjoint A by det A. But without finding the determinant and adjoint, using row operations, we can find the inverse of a non-singular matrix. That is called Gauss-Jordan method. We discuss in the next class. Right? Thank you.